everybody, gather around. We've got another living environment lesson on deck. Don't be shocked. It's just another lesson. All right, let's get started. Where are we? 1, 2, 3. All right, so we assessed our coronavirus hijacking our cells. A lot of people did really well on that. A bunch of people revised with me on Wednesday. That was great. Got some scores totally boosted. So we talked about the first part of our immune system on Tuesday, and here we are today. We're going to talk about the second phase. Okay, so what we've learned so far, the background information about coronavirus, we've learned how a virus infects our cells, and the first steps that your body takes to fight an infection. Where are we going? We want to learn about the specific immune response. That's sort of the second phase of your immune system, and how does that fight infections? So let's just cover a little bit of what we learned on Tuesday. If you remember, these were our big questions. So your first question was to explain how macrophage identifies a pathogen. So on Tuesday, we learned that our body uses antigen receptor matching to identify the pathogens. In the comic, it showed us this really great visual. This is the macrophage's membrane. And it has its receptor molecules. The receptors, he's sort of like poking the germ. The receptor is connecting with the antigen on the germ. All right, so each of these red items is our antigen. So this idea of receptor antigen matching is super important. It really triggers every step in the process. So I wanted to shout out one great answer that I saw. So I think this was Sam. The macrophage uses its receptors to check the membrane. If it has an antigen that matches with the macrophage, if it matches up with the bacteria's membrane, the macrophage eats it up. Great. So the receptor on the macrophage has to match with the antigen on the pathogen. All right? If it matches, they're going to eat it. All right, so next step in your assignment was to give us the functions of each of these different types of the cells. So I kind of organized them in groups. Our macrophage here, his function was to eat and destroy pathogens. But he has a second function too. He can also send for help, right? He can send a signal that's going to get some help to come. These neutrophils are another type of white blood cell. They're both white blood cells. The neutrophils' job, really simple job, eat and destroy pathogens. That's what they do. All right. Okay, next, guys. So we met two other types of cells. These are also things floating in our blood. So platelets and fibroblasts, they have the same job. Their job is to close up a cut or a wound. So the platelets stop the bleeding, and then the fibroblasts make those long-term repairs. And the last cell that we met was our dendritic cell, and its job is to send signals for more help as well. It does it in a slightly different way than the macrophage did, but in general, our dendritic cell is going to start the second phase of our immune response, and I'm excited to teach you guys about that today. Our last question was about how do different cells in the immune system communicate with each other. Basically, they use chemical signals, and we have this great image here. The macrophage is sending a chemical signal. Somebody in our live lesson, we described it as almost like when you smell something, and so like you walk in the door in your apartment and your parents are cooking a delicious meal, and the smell wafts over and hits your nose, and immediately you're like, oh, I'm so hungry. Our chemical signals work sort of like that. So the macrophage is sending out this chemical signal, and when it hits the right receptor on another cell, it's going to trigger that cell to do whatever that chemical message says. Does that make sense? I hope that helps. Another person explained this well here. I want to say this was Jalen. I could be wrong. I'm sorry if this is somebody else and I think it's Jalen. Okay. Different parts of the immune system send signals or messages to each other using chemical signals. For example, macrophages sent chemical signals for help, and the human cells were able to get the message and send the neutrophils. Exactly right. All right, so today we are going to learn about the specific immune response, and this is a case where your immune system is responding to a specific pathogen. In a specific immune response, your body begins to fight the specific pathogen that is infecting your body. By focusing on one specific pathogen, this immune response is faster, stronger, more efficient. We're going to meet a bunch of new cells, lymphocytes, plasma cells, memory cells, and antibodies. How are we going to learn all this? Same system as yesterday. So you're going to read pages 10 through 16. It's just the second half of the comic. And you're going to learn about the second line of defense, or sort of the second part, the second stage in your immune system response. Answer the questions on Google Classroom, which will help you summarize what you've read. Same document, right? So here, the day 2 is just on the second page. The big questions I want you to hold in your head while you're reading is, how does your body activate a specific immune response? How does it start? How do antibodies help fight infections? And what is the difference between specific and non-specific immune response? So this is sort of the big idea between Tuesday and today. What's the difference between what we learned on Tuesday and what we are learning about today? All right, customize your order. Same system as last time. So if you felt really confident reading the comic and feeling good about it, and you're ready to go solo, then go ahead, order your extra cheese. If you want a pepperoni pizza, then stick with me. I'm going to start reading the comic right now. And if you're looking for a deluxe order, then you are more than welcome to join us at 124 live lessons. We'll read together and then answer our questions. Anybody who's come to like live lessons lately, or even Wednesday office hours, like we've been able to really finish our assignments together, so might be fun. Just come to live lessons. Could be good. Okay. All right, let's get started. If you are all done and you're ready to go do your comic, then goodbye. We'll miss you, but proud of you too. And if you're ready to read with me, then pause right here, open up your comic, and let's get started. All right, here we are, On Guard. So we read pages 1 through 9 last time. And let's just get sort of to the end here of page 9. All right, here's where we ended, just to do a little reminder. The dendritic cell arrived at the wound, and Mac, the macrophage, is saying, wow, we really need some help. So Denny says, hi, Mac, we need more expertise. We need a specialist who understands this particular kind of bacteria, and I know just who can help my friends in the lymph nodes. I'll just take a sample to show them. So he's going to take a sample, and the germ is like, sample? And he eats up the germ, spits out a little piece. This is an antigen. That's what he's spitting out. And the skin cell's like, hurry! While the battle rages back at the site of the infection, Denny slips through the wall of a lymph vessel and travels to the distant lymph node. Denny's mission is to activate specific immune response, especially tailored to this specific infection. Coming into a lymph node, the home of the lymphocytes. So Denny's arriving in the lymph nodes. He says, where do I even start? Just a quick summary. So far, last week we saw the non-specific immune response, and now the dendritic cell is going to start the specific immune response. The dendritic cell takes a sample antigen to the lymph nodes. Excuse me, we've got some germs going nuts in the right thumb. Does anybody recognize this sample? So he's kind of like, you can see this little Y things. He's trying to figure out, do any of these lymphocytes, do any of them match? They're all like, nope, nope, sorry, nope, not mine, nope, sorry, can't help you. So on and so forth. There are millions of lymphocytes, and each one carries a different kind of receptor on its membrane. The dendritic cells is trying to find a match for its germ sample molecule called the antigen, right? This search can take a long while. So you can see he's trying to match the antigen from before to the correct lymphocyte. Later, come on, anybody? Nope, nope, not even close. Then this guy, this little lymphocyte's like, hey, that's my shape. That's my antigen. So this guy actually matches. Summary. The dendritic cell checks all of the lymphocyte receptors for the one that matches the antigen from the bacteria. Finally, it finds one that matches. Okay, here we go. The activated lymphocyte starts dividing. All of its daughter cells have the same receptor, right? This is just mitosis, so these guys are all identical. Some of them, so this group over here, becomes memory cells. Memory cells will remain on the lookout for future infections by the same germ. The other branch of daughter cells turns into plasma cells. These cells generate antibody molecules that match the germ's antigen. Each plasma cell can crank out about 2,000 antibody molecules per second. All this antibody is being released into the bloodstream and floods the entire body. All these little Y-shaped guys, these are the antibodies. They're just, these plasma cells are pushing them out. They're like growing these, creating these antibodies, and the antibodies are going right into the blood system. Matching lymphocyte starts to divide, creating two types of cells. The memory cells, which will keep a lookout for future infections by the same pathogen, and plasma cells will create antibodies that flood your bloodstream all over your body. Back at the infection site, hey, these are the macrophages, right? They're saying, hey, Denny must have found the correct lymphocyte. Here comes some antibodies. And now the antibody starts to do its thing. Click. Hey, what's that? Each antibody molecule has a basic Y shape. The arms have the parts that fit perfectly into the antigen structure of the germs for which they are generated. Get off of me! Get it off me! So these guys are clicking onto the antigens from this germ. The antibody interferes with the function of germs. It can make them clump together, sort of like slows them down. This guy's like, I can't move right. I can't eat right. This stinks. And while the arms of the Y are different from each, and while the arms of the Y are different for each kind of germ, the immune system fights. The base of the Y, so this part, sends the same strong signal to the cells of the immune system. Eat me, eat me, eat me. And this guy's like, oh. Antibody molecules tag germs for faster, more efficient destruction. They send their germ-eating white blood cells into a feeding frenzy and give them a better grip on their prey. So it makes all these pathogens slow down. It sets off like an alarm, like, hey, I'm bad, eat me, eat me, eat me. And all of these pathogens then can just all of these macrophages and neutrophils can really finally eat them all up. Pretty soon, it's all over. Good job, everyone. I just gotta mop up these dead neutrophils now, which is pus, if you remember. This guy's like, oh, I'm so full. The skin cells are like, whew, glad that's over. Yes, macrophage eat pus. You're welcome. Ew, gross. All right, summary. With the help of the antibodies, the macrophages finish cleaning up the infection, even eating the pus from the dead neutrophils. Blech. Every time a new kind of germ infects the body, the immune system starts this process from the beginning. First responders like the macrophages and the neutrophils launch an inflammatory response, doing their best to control the infection until the lymphocytes can help the body adapt to fight the specific kind of germs involved. I think that's really important and really helpful. So I'm going to read that one more time. Every time a new kind of germ infects the body, the immune system starts this process from the beginning. First, the first responders like macrophages and neutrophils launch an inflammatory response, doing their best to keep the infection under control. Then, once the lymphocytes can help and send the antibodies, that is like the second phase, and that's when they start fighting the specific kind of germ that's involved. But if the same kind of germ tries to reinfect the body, the immune system is several steps ahead. Haha, I'm in! I'm going to. You might remember this guy. This is the memory cell from before. He's like, wait a second. I remember you. The memory cells generated during the earlier infection make it easier to launch a fast, overwhelming response. He's like, hey, I know you. You're not allowed in here. And this guy's like, I smell antibody. Is there anybody to eat? And this guy's like, nope, it's all taken care of. So the immune system learns from its past experiences and adapts to fight familiar enemies more effectively. This process is called immunological memory. Next time the pathogens infect your body, the memory cells and the antibodies will be ready to fight the infection even faster than before. For many diseases, a process called vaccination can give immunological memory a head start. Vaccinating against a germ usually involves injecting them with the antigen from that germ. The antigen gets lymphocytes ready to prepare memory cells that will be on the lookout for that kind of germ. That guy's like, oh, it's my shape. That way, when the immune system can remember a disease, even though that person's never had it before, he's like, hey, haven't I seen your ugly mug around somewhere? In addition to fighting off germs from outside the body, the immune system is also on the lookout for cancer, the out-of-control reproduction of the body's own cells. Cancerous cells have been damaged in a way that makes them forget how to cooperate with the rest of the multicellular community. They spread aggressively, hogging space and resources. They're like zombie cells. They're just like growing. And these guys are like, hey, these cells are human, but I'm detecting cancer antigens on their membranes. And he's like, they're no longer part of the team. Attack. Bacteria, viruses, cancer, if it's not one thing, it's another. But the cells of the immune system are on guard 24/7, working to keep the whole body healthy. Keep a lookout, everybody. This guy's like, the end. All right. Awesome, guys. So let's flip to your Google document. If you have questions, just, keep looking back in the pages for where you'll find those answers. There's hints in there for everybody. And if you still feel confused, come to live lesson. We'll work out all of this material together. All right. Thanks for reading with me.